Good afternoon. This is AP Calculus AB, and this is our Friday before homecoming lesson. And would you do me a favor? You just close the door there. It's a little quieter in here. Just a quick announcement about the homework. You knew how to do 11 and 14. It turns out 23 star and 25, you do not yet know the derivative of sine and cosine, or at least I haven't taught them. So if you were confused on 23 and 25, that's all right. Just go ahead and do those. Since we're learning those today, do those as part of what you turn in on 2.2b. So if you struggled with those, if you didn't understand, that's all right. There's a reason you didn't understand. We're going to start out the lesson with those today. So go ahead and take out the handout that you were working on yesterday. We're doing the shortcuts. And right at the end of the handout, there was a blank page. And so this was the end. This is what it looked like right at the end. If you turn the page, the next page should be blank. So this is the page on which we're going to find out what is the derivative of sine theta, or sine of x, and what's the derivative of cosine x. So let's jump right into that. I would like you to, first of all, look at quick sketch 48, 49, and 50. See if you remember these. Quick sketch 48 was the function sine x over x. Just do a small little quick sketch right up top. See if you remember what the shape of that graph was. When you're done, look up here, see if we agree. I've got it here in red. Does that ring a bell? Does that look like what quick sketch 48's graph was? Sine x over x has a hole at 0, 1. How about this one? Quick sketch 49 was y equals the absolute value of x divided by x. See if you remember what that quick sketch came out to be, and then sketch it, then look up here. Hope you have a piecewise function. Half of it's at y equals 1, the other half at y equals -1. And then finally, quick sketch number 50 was y equals 1 minus cosine x over x. What did the graph of that function look like? Try it on your own, see if you remember. That one also has a hole. It bounces from above to the right, and it bounces from beneath off to the left. These are going to be really helpful quick sketches to have in mind as we try to find the derivative of sine x. So, on the blank side, let's look at problem 1. Let's look at f of x equals sine of x, and let's use the definition of the derivative to find f prime of x. Let's begin with the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, I'm not going to turn you loose completely, but would you try the next line on your own? Then when you're done, peek up here, see if we agree. There it is. I hope you have the sine of x plus h minus the sine of x all over h, taking the limit as h approaches 0. Well, it sure would be nice to know what the sine of the sum of two numbers is. Wait a second. There's a chant for that. Let them hear you on the internet. Ready? Go. Sine, cosine,
cosine, sine, cosine, cosine,
sine, sine. No one went on to tan, tan, 1, tan, tan. That's right, if you can't do it, no one can. Let's use the first half of the chant to get f prime of x equals the limit as h approaches 0 of sine, cosine, cosine, sine. goes alpha, beta, but in this case, alpha is x, beta is h. So there's sine, cosine, sine, minus sine x all over h. Now, how on earth are we going to deal with this limit? Well, first of all, I can distribute the denominator to each term in the numerator. So I believe the next line is going to be the limit as h approaches 0 of sine x cosine h over h plus, in fact, I'm going to take the limit of each one individually, the limit as h approaches 0 of cosine x sine h over h minus the limit as h approaches 0 of sine x over h. Let's just pause there to make sure this is not going too quickly. Do you have any questions as to how I was able to pull this off? Okay, yeah, Crystal.
Do you need to write limit of h approaches 0 for like every single?
Yeah, I'm choosing to do that because I'm permitted to do it because the limit of a sum is the sum of each individual limit. So we're allowed to do that. We'll see if that's actually helpful. It's actually a crucial part of this. So since we're allowed to do it, let's exercise our freedom. And interestingly, sine h over h. Keep in mind that if we're taking the limit as h approaches 0, then cosine x is really functioning as a constant. X isn't moving, h is on the move. H is moving towards 0. So you can, cosine x is like a constant that comes out front. Nothing's happening to that. What is the limit as h approaches 0 of sine h over h? Based on, yeah, it's got to be 1, based on quick sketch number 48. So that's 1, and 1 times cosine x is cosine x. Because the limit as h approaches 0 of sine h over h is 1. Now, these other two limits both have a sine x, so I'm going to combine them into one. I'm going to combine them into the limit as h approaches 0 of sine x cosine h minus sine x all over h. So the first limit and the third limit, I'm combining them over the common denominator so that we can make the following observation. And I notice that I'm out of space here. Hopefully you're writing smaller than I am. Let me just condense this a bit, and we're back. Friends, look at what's going on here. If you factor the limit as h approaches 0, factor a sine x out of the numerator, we get sine x times the quantity cosine h minus 1 all over h. It's quick sketch number 50. You've heard of Hawaii 50, maybe not. This is quick sketch 50. And what is, based on quick sketch number 50, what's the limit as h approaches 0 of cosine h minus 1 all over h?
0.
It's 0, and 0 times sine x is 0, which means that the derivative of sine x, f prime of x, the derivative of sine x is cosine x. That's the results that you needed. That's one of the results you needed in order to really complete homework 2.2a. So just do that problem where you had to, just take a peek at homework 2.2. Yeah, now we see why it is that I took the derivative of sine x and wrote cosine x. It wasn't x, it was theta. Now we have to find out why is it that the derivative of cosine theta is negative sine theta. We haven't done that one yet, but there is a cycle of length 4. So hopefully you'll be able to fit this on to the sheet of paper that you're working with. On your paper where we just derived this, let's take a look at, I have room to put the cycle of length 4. It's not all that long, but hopefully, let's see how much room you have. Oh yeah, I see. It looks like you've been managing your space well. I see a lot of people, whoa, you have all the space you need in order to get the cycle of length 4. This is, I'm going to call this the trig derivative cycle of length 4. Honestly, I just came up with that name off the top of my head moments ago. The trig derivative cycle of length 4. Okay, here's how this rolls. We'll actually put the cycle of length 4 down here. We have to draw some pictures up top. It's going to be f of x versus f prime of x. So for sine x, it's a first step in the cycle here, making this black. So for sine x, we just discovered that its derivative is cosine x. That's the first step in the cycle. Now we're going to find the derivative of cosine x. Well, check this out. You probably could have guessed that the derivative of sine x was cosine x by looking at the graph of sine x. Check this out. Sine x, color for that is blue. Here's one period of the sine x graph. It's actually continuous. There's no real endpoints on it, 0 to 2 pi. Its domain is really negative infinity to infinity. Its range is negative 1 to 1. And we could imagine what the slopes of the tangent lines would look like in orange. What do you think what does it look like the slope of the tangent line at x equals 0 on the sine graph is, class? Yeah, if you were to approximate, it looks like it's probably about 1. Well, guess what? The cosine of 0 is 1. It's actually exactly 1. How about at pi over 2? What does it look like the slope of the tangent line drawn to the graph of sine x is at pi over 2? Some of you are signaling 0 to me. It's actually correct. How about at pi? The sine of pi is 0. What does it look like the slope of the tangent line at 0 is? Negative 1. So it goes 1, 0, negative 1, 0, 1. Sure enough. Those are values that are consistent with the graph of cosine x. We just proved, with great care and effort, we just proved that the derivative of sine x is cosine x. But we probably could have guessed it by just sketching the graph of f prime of x based on the graph of f of x. Do you see how that would have been a reasonable guess? Just a guess. So we proved it. It was a guess. Well, you know what? Let's go green here. To get the derivative of the orange graph, would you please do like I did on the blue graph? Draw tangent lines to the orange graph at 3 places, or at 5 places, and try to sketch the graph of the derivative of the orange graph based on the slopes of the tangent lines. What does it look like this, the equation of the derivative of the orange graph might be? I mean, it looks like on the orange graph, the slopes are going 0, negative 1, 0, positive 1, 0. What's the equation of the sinusoid that looks like this? Raise your hand if you think you know. Yeah, it's the blue sine x graph reflected over the x-axis. It looks like it's the negative sine x graph. You can actually prove, using this limit as h approaches 0 approach, that that's the case. You can prove it. So the derivative of sine is cosine, the derivative of cosine is negative sine. The derivative of negative sine, go ahead and take it one more, go to the third step in the cycle. Go ahead and sketch the graph of the derivative of the green graph and write down what you think the answer is going to be. And then check with a shoulder partner or someone nearby based on what your guess is for the derivative of negative sine x. check in with someone nearby, see if you can come to an agreement as to what the derivative of negative sine x might be. Don't be shy. Go ahead and talk about it. And then raise your hand if you find someone who agrees with your answer. What does it appear? All right, Crystal.
Negative cosine x.
I'm going to switch over to red for this. Negative cosine x does appear to be the graph of the derivative of the green graph, because the green graph has slopes of tangent lines at -1, 0, +1, 0, and -1 is what it appears to be. We could prove it using the algebraic approach, but yeah. And then the derivative, although truth is, it's got to be the case, because if the derivative of sine x is cosine x, then the derivative of negative sine x is going to be the opposite of that. You can just treat -1 as a scalar multiple, it comes out front. So now when we go to the fourth stage, it cycles back to the beginning, because you can find the derivative of negative cosine x based on the derivative of cosine x. If the derivative of cosine x is negative sine x, then the derivative of negative cosine x would be the same thing except multiplied by -1. That takes us back to the beginning. So the first derivative of sine x is cosine x. The second derivative of sine x is negative sine x. The third derivative is negative cosine x. By the time you get to the fourth derivative, you've cycled back to the beginning. That's why we call it a cycle of length 4. So when it comes to doing problem 25, one of the parts will be to come up with the derivative of cosine x. That's why we can see in the solutions it says negative sine x. So that's what you'll be doing. Just turn that in as part of what you turn in on Tuesday. Any questions on derivative of sine x or the derivative of cosine x? Now's your chance to ask. All right, now you have enough information then to complete the homework that's due on Tuesday. I'm going to move on to the product rule and the quotient rule. So what I'm teaching from here on will be for homework that's due on block day of next week. So raise your hand if you do not want a paper handout. So I see you, because you're taking notes on your Surface. Okay, thanks. You can put your hands down. That tells me. I'm going to adjust my copy numbers accordingly from here on out. So there we go. Alrighty. Those of you who are taking notes from the video, just go to Unit 2, and these handouts, they're all right there. They're just one PDF that has all these documents. All right, here we go. Let's go to the product and quotient rule, which begins with a review. So up top here, page 1, there's a review of things we've already learned. Well, at least these A and B are a review. C, D, and E are what we're learning today, the product rule and the quotient rule. So try parts A and B on your own. See if you can remember, without referring to your notes, what is the derivative with respect to x of C? Did anyone name C when it was born? Lowercase c, yep. It has meaning, it's a symbol with meaning. Someone defined it as a real constant. So C is a constant. U is defined right here as a function of x. So U could be sine x, it could be e to the x. It's just some function of x. So if you want to write down the answer the short way, is just C comes out front. C is a constant. It's a scalar multiple. So you just take the derivative with respect to x of u, which is going to be u prime, And C times U prime, that's the answer. Now, if you wanted a longer version of the answer, you could write this as C times du dx. C times du dx would be another form, but why spend more time writing when you can just write this? Let's use this shortened notation so that when it comes to the derivative of a sum, just write the sum of the derivatives in streamlined fashion. Just write, well, you tell me what to write. What do you think the most streamlined version of the answer to the sum or difference rule is? Volunteer on this one. What's the derivative of u plus or minus v? All right, Elijah, do you want to try that?
U prime plus or minus v prime.
That's it. Instead of taking all the time to write du dx plus or minus dv dx, just write u prime plus or minus v prime. Now, right up front, you may as well know. The limit of a product is the product of the limits. But the derivative of a product is not the product of the derivatives. So many students think, oh, I know what the derivative of uv is. It's u prime v prime. No. No, when you're taking the derivative of a product, it's actually more complicated than that. It's not u prime v prime. Instead, you have to use the product rule. You can look at the proof for it in the book. We look at it more in depth in a course that if you become a math major, you'll in a course called analysis, you'll go back and prove this. But for now, we just want to give you the product rule and teach you how to use it. It is u prime v plus uv prime. That's the product rule. And when I'm using the product rule, there are words that flow through my mind that kind of keep my head in the game. So I think of u as the first factor, and v is the second factor. So here's what I say, and I'd like you to say this too, once I teach it to you. So here we go. It's derivative of the first times the second plus first times the derivative of the second. Those are the words that flow through my mind every time I apply the product rule. So when I say go, I would like all of you to say out loud and in unison, and I know some of you have other things out, you do other things. Go ahead and put everything else away except for this handout. We need you to stay focused in on this. I'd like all of you to say out loud and in unison, derivative of the first times the second plus first times the derivative of the second. Ready? Go.
Derivative of the first times second plus first times derivative of the second.
That's how it goes. And this pattern is the same if you should happen to have three factors, it just goes UVW plus UVW plus UVW, where on the first term you take the derivative of the first factor, in the second term you take the derivative of the second factor, and in the third term you take the derivative of the third factor. So, excuse me. So there's the product rule for when you're taking the derivative of a product of three factors. Now, in a few moments, we'll learn the quotient rule, but for now, let's just let you know that's the new material. The emphasis of today's lesson is going to be on the product rule. Then we'll do a little bit with the quotient rule. Now, these are reviews. Roman numeral 2, go ahead and write down in the most streamlined notation possible what would be these four derivatives. Go ahead and write them down. This is review. So you should be just quick review. When you're done, look up here, see if we have it. Okay, I have the four answers up here. And usually these are a little bit surprising, or at least usually some of these are at least a little bit surprising for at least some of the people. So now's your chance to ask questions. Which of these are surprising to you, or would you like to challenge, perhaps push back on, or just ask about? Out of curiosity, raise your hand if you had these 4 answers on your own. It's like, these are the 4 answers you had. Okay, all right. So if you were grading yourself on this, are you saying a couple of you would give yourself a 2 on this? The rest of you would give yourself a 1? Is that it? It's like you understand it now. Is there anyone who's got a 0 on this? It's like, yeah, I want to ask about this, or I don't understand this. We're good to go? All right. Then Roman numeral 3, we don't know these two yet. We need the quotient rule to get these, but we do know the derivative of sine x is cosine x, and the derivative of cosine x is, what is it again?
Negative sine.
Negative sine x is correct. Okay, so let's practice using the product rule. Go to page 2. And when it comes to which one is the first, which one is the second, we do have a product of 2 functions. Now, you could think of the first as x to the negative 2, and then just think of 5 as a scalar multiple, and when you're done, multiply everything by 5. I do not recommend that. If you think of this as 5 times u times v, then that usually results in some silly mistakes. I strongly recommend when you say first in your mind, first make it just 5x to the negative 2. So u is 5x to the negative 2. V is x plus 3. So when you're trying to find the derivative f prime, set up a skeleton of the answer. Then we'll attach flesh to the 4 bones. Got derivative first, second, plus first times the derivative of the second. Here's a skeleton. Every product rule derivative has 4 parts. So just set up the skeleton and then attach flesh to these 4 bones as your next step. So the mantra that's going to be rolling, well, let's not call it a mantra. Let's say the short narrative that's going to be running through your mind will be derivative of the first times the second. So I'm just going to write, I'm going to say derivative of the first, but I'm going to write negative 10x to the negative 3. Derivative of the first times the second plus first times the derivative of the second. Those are the 4 bits of flesh that get attached to the 4 bones. Any questions as to where I came up with these 4 expressions? Yes, go ahead.
How did you get the 1?
Well, derivative of the first times the derivative of the second. The derivative of x plus 3. X plus 3 is a sum. So the derivative of a sum is the sum of the derivatives. What is the derivative of x with respect to x? What? Sure. The derivative of x is what? The derivative of 3 is 0, but the derivative of x is 1. And if it's like there's a lot of stuff going on at once, but it's 1 times x to the 1. So when you take the derivative with respect to x of this, you take 1 times 1 is 1 times x to the 0, but x to the 0 is 1. So, but if you think about the slope, I mean, that's parent graph number 1. That's your first parent graph. And the slopes of those tangent lines are always 1. So, by the way, there's not going to be a big emphasis today on simplifying your answer. I mean, sometimes we will, but I mean, this is a calculus class. Sometimes we skip the simplification part. If you were to simplify this, I mean, it's doable. You can simplify it. You would get f prime of x, switching to green, you would get f prime of x equals negative 10x to the negative 2 minus 30x to the negative 3 plus 5x to the negative 2, combining like terms to get a final answer of negative 5x to the negative 2 minus 30x to the negative 3. So if this were a multiple choice test, this would probably be the form. I mean, this might be the form. Who knows? They might get rid of the negative exponent. It's hard to say. But there is a second part of this problem in which they ask you to find f prime of c when c is equal to 1. So f prime of 1 is just negative 5 minus 30, or negative 35. just plug in a 1 in for x. The output of the derivative function is negative 35. So that was problem 1. And before I turn you loose to attempt problem 2 on your own, do you have any questions on problem 1, our first example of the product rule? Okay, well, set up a skeleton for number 2, the skeleton for finding the first derivative using the product rule. Then I'm going to tour the room. I'll pause the camera, so if you're watching at home, just you can pause the camera. Also, when you're done, you can take a peek, see how you did. Welcome back. All right, so would you help me out? What goes in this first expression? Paul, go ahead.
3x squared.
There's a little bit more.
Oh, minus 3.
Derivative of the first. For the second, I just copy it down, 2x squared plus 3x plus 5 e to the x. So it's derivative of the first times the second plus first, just copy it down, x cubed minus 3x, times the derivative of the second. What is the derivative of the second function in this product? Help me out with that. Please volunteer to tell me the derivative of the second. All right, Adam, go ahead.
Oh,
What is the derivative of this trinomial?
I don't know yet. Working on this.
That's right, just try it on the fly. I mean, it's the derivative, just take the derivative of each term individually.
4x
4x
plus 3
plus 3,
plus isn't it just 5?
it's 5 e to the x. That's right, because the derivative of e to the x is e to the x, just multiplied by 5, there it is. Now, friends, I'm not going to ask you to go through and do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiplications and combine like terms. Okay, that's, relax. That's not what you're going to be doing on the AP test. It's a 3.5, 4-hour test, summarizes the whole year. They're not going to give you problems where you have to spend 12 minutes multiplying stuff. That's not the College Board that you and I know. They just give you reasonable tasks to accomplish in the amount of time they're given. So, by the way, if someone did ask you to find f prime of 0, I mean, it's not too hard. We just got negative 3 times 0, well, actually it's 0 times 5, 0 plus 5. So that one's actually 5. So you don't need to simplify it to evaluate it at x equals 0. 0 plus 5 times e to the 0, that would be 5, plus 0 times, oh, it doesn't matter anymore because we're multiplying by 0, so the answer is just negative 15. Alrighty, questions on problem 2. By the way, I am accepting, same on the homework, if we ask you to find the derivative, unless it's a multiple choice problem, just leave the derivative in unsimplified form, unless the directions require otherwise. And now number 3. In problem 3, it kind of looks like a quotient rule. It looks like u divided by v. But really, most quotient rule problems can be re-expressed as product rule problems. If you don't believe it, here, I'll prove it. X to the 5th minus 3x. Isn't division by x squared the same thing as multiplication by x to the negative 2? So I've converted this quotient rule problem, we haven't even learned the quotient rule yet, I've converted it to a product rule problem. So now, would you please finish this one? Actually, just forget the c equals negative 1. Just go ahead and find f prime and then pause. Find f prime of x and then pause. I'll do it up here. Then when you're done, check. I took the derivative of the first times the second plus first times the derivative of the second. We're good to go. Any questions on that one? Number 3. Okay, I think you get to practice on the next page a little bit. So, next one, I would like you to simplify. Try problem 4 on your own. Please find f prime of x. Now, if this had been multiple choice, then it could be expressed in factored form. They might factor out an e to the x. So you get e to the x times 1 plus x. And on number 5, let d could tag along with either the first factor or the second one or the other, but not both. Don't distribute the d to each factor. But try number 5 on your own. Find f prime of x. Okay, so do you find that writing out the skeleton helps you organize your thinking? Yeah, skeleton I think is helpful, so I hope you're using it. Any questions up to number 5? Okay, it's time to switch over to the quotient rule, so let's flip back to the front, page 1. Let's write down the quotient rule. What's the derivative of u divided by v? There is a mnemonic device for this. I mean, sure, I can just write it down. I know what it is. It's v u prime minus u v prime. In the numerator, draw the line over v squared. You're like, what? There's a really smooth mnemonic device that'll make this a breeze. Remembering this, I mean, can we just be honest with each other? Doesn't it look like remembering this could be intimidating? It's like, how am I going to remember that? Is there anyone who's willing to admit, I won't call on you, but is anyone willing to admit that this looks like a tough thing to remember? Thank you for your honesty. Thank you. I have a poem for you. In this poem, when you hear the word low, that just refers to the denominator, v. When you hear the word high, that's a reference to the numerator, u. When you hear the word d, that's short for derivative. Here we go. Ready for this part? Wait, hold on. Time out. Time out. Pencils down. You got to take this in. You got to take this in. It's a poem. How often do you get a poem? Like every other day? Here we go. Low d high minus high d low. Draw the line and square below. That's the quotient rule poem. Once again, low d high minus high d low. Draw the line and square below. Low means denominator. D high means the derivative of the numerator. So it's low d high minus high d low, draw the line and square below. When I say go, I'd like all of you to say out loud and in unison, low d high minus high d low, draw the line and square below. Ready? Go. Low d high minus high d low, draw the line and square below. Whoa, it rhymes. Here's how we use the quotient rule. Let's go forward to our first quotient rule opportunity. Here we go. Quotient rule. Here it is. Low d I minus I low, draw line square below. So if you know that poem, then the skeleton for the quotient rule is going to go like this. For y prime, just set up the skeleton at low d high minus high d low, draw the line and square below. So here's how I would think through it. I would be writing low for d high. Let's write 0, because I know the derivative of 1 is 0. So it's low d high minus high d low. Draw the line and square below. Low d. I was able to actually do the math at the same pace I was reciting the poem. I did low d high minus high d low. Draw the line square below. By the way, this simplifies pretty nicely. Because of the zeros, we've got y prime equals -5 over the quantity 5x minus 3 squared. Not much to it. Here, you practice one. Try number 2 on your own. Set up the quotient rule skeleton and attach the flesh to the bones. Have at it. Moves along pretty quickly. Taking derivatives isn't nearly as time consuming as you may have feared. I've got low d high minus high d low up top. I drew the line, I squared below. Raise your hand if that's the answer that you came up with when you did this. Let's see, wow, there's hands going up throughout the region. Any questions on this one? Well, there's more work to do with the quotient rule, but we're going to finish that on Tuesday because this product rule and quotient rule homework is not due on Tuesday. We're just kind of getting into it. So just have assignment 2.2, whether it's anything from 2.2a, 2.2b, that should be done by class time on Tuesday. Have a good weekend.